Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. We have been dealing with strings which are light and inextensible. In that case of ideal strings, tension at every point is same. Now what if the string has got certain mass? So consider a rope of mass m and a block of mass capital M is suspended to that with the help of the rope. What is the tension at different points A, B and C? The first point to be understood is that if the string has got certain mass, the tension is different at different points. So this example would clear the concept. So the way how you work with string with a mass is like this. Suppose I want to find the tension at the midpoint. So consider B to be the midpoint. At this point I have to find the tension in the string. So break the system into two parts at that point. So if you break the system into two parts at that point, you have got a block of mass m and a rope of half the length, so half the mass. So consider uniform mass distribution. So half the length is half the mass. Now at this point, now consider the forces acting on the system. My system is m plus m by 2. So the weight acting on this is m plus m by 2 into g, and at this point there is tension which is acting, that is Tb. So if you break the system into two parts, and you can take any of the parts and analyze by drawing the free body diagram. Now this part of the system is in equilibrium, acceleration is 0, so the net force must be 0. So Tb is simply m plus m by 2 into g. This is the value of tension at the midpoint. Suppose I have to find tension at this point C, then break the system at point C. If you break the system at point C, there is only this block M. So the forces acting on this block M are mg downwards, and this is point C. The point C is pulling it up, Tc. The block is in equilibrium. Tc is equal to capital M G. Suppose if you have to find the tension at point A, the topmost end, then so consider the system. So now it is the entire rope and the block. The forces acting on these two things taken together is m plus m into g, and the tension at this point is A, Ta. So Ta is equal to m plus m into g in equilibrium. So the tension at the topmost point is m plus m into g, at the midpoint is m plus m by 2 into g, and at the bottommost point it is simply capital M into g. Now let us take another example. Say two blocks connected with a rope of mass small m, and a force F is applied on M2, and the system is placed on a smooth horizontal floor. I have to find tension at point A. A is at a distance L by 3 from M1. We'll apply the same logic. So first let us find the acceleration of the entire system. Because two blocks are connected with a single rope, two blocks plus rope all together are moving towards right with some acceleration A. So if I take m1 plus m2 plus m as my system, net force in the horizontal direction is F, that is equal to mass into acceleration m1 plus m2 plus m into A. So acceleration of the system is F by m1 plus m2 plus m. Now my target is to find the tension at this point A. You can split the system into two parts and choose any one. If I choose the left part of the system, it is easy for me to get Ta, because there is the only force acting on the system in the rightward direction is Ta. So what is the left part of the system is m1 and L by 3 length of the rope, which is having a mass of m by 3, because for L length it is m, for L by 3 length it would be m by 3. Now in the horizontal direction, the only force acting on it in the rightward direction is Ta. Of course in the vertical direction there is weight and the normal force. We are not bothered about it, and it has got acceleration of A. Every part of the system is moving with an acceleration A, that is equal to F by m1 plus m2 plus m in the rightward direction. Now applying Newton's second law here, Ta, net force, is mass into acceleration, that is m1 plus m by 3 into A. So tension at point A is m1 plus m by 3 into acceleration A, that is F by m1 plus m2 plus m. As simple as this. Now if you have to find the tension at the midpoint of the string, I think you can try it and post your answer in the comment section. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.